Okay, so this is the continuation of the lecture on linear equations. So uh, last time we left uh, studying what are equations. We talked about what are equations, what is a variable, what is a linear equation, and what is a solution to a set of equations. And I told you last time, or I promised you last time, that in this lecture, and then I told you last time that in the next lecture, we would look at how to solve given any general equation or given any general set of equation of the form a1x plus b1y equals c1 and a2x plus b2y equals c2, how to find out what is the value of x comma y that satisfies these two equations simultaneously, or what is the solution to this set of equations. So I will quickly touch upon these methods. You must have learned this in your high school days, but I will quickly touch upon these methods. So one of the methods is what we call as okay, I'll just show you the methods very briefly. Suppose I have an equation that x plus 2y is say 3 and I say 2x plus y is 4. Okay, I need to find the value of x and y such that these two conditions are satisfied. Okay, now the idea is one of the ideas to solve this equation is that okay, x plus 2y is 3, all right, which means if x plus 2y is 3, I can just multiply both sides of an equation by 2. Isn't that wrong? No, it's not wrong, right? If x plus 2y is 3, if someone says mm, if 2 equals 2, if I multiply both sides by 2, that means 4 equals 4. So if x plus 2y is 3, that means 2 times x plus 2y. X plus 2y is a number, right? So 2 times that number must be 6, which means 2x plus 4y must be 6, right? So now finding a solution to this is the same as finding a solution to this, right? This equation and this equation are the same thing. Here you are saying that x plus 2y is 3. I'm saying, you know what, 2x plus 4y is 6 is literally the same thing. So if I'm able to find a solution to this set of equations, I have found a solution to this set of equations. Now you might say, how has that solved the problems? I've just created another set of equations from a set of equations. However, note that now both of these terms are the same, which means the coefficient of x is same in both the equations. It means, okay, 2 times x plus 4y is 6, 2 times x plus y is also 4. So now if I subtract these two equations, or let me not explain it in that way. Let's say 2 times x plus 4 is now 6, right? So that means 2 times x is 4, 6 minus 4y, right? If I just bring it on the other side, if 2 times x plus 4y is 6, then 2 times x must be 6 minus 4y. But at the same time, 2 times x plus 2 times x should also be equal to 4 minus y, because I want a solution. I want a value of x such that both of these are satisfied at the same time. So 2 times x is 6 minus 4y. At the same time, 2 times x must also be 4 minus y, which means if 2 times x is 6 minus 4y, at the same time 2 times x is 4 minus y, that implies 6 minus 4y must equal 4 minus y. And now I can just bring this on this side and take this here. So 6 minus 4 is just 3y, and that means 3y is just 2, which means y is just 2 by 3. And if y is 2 by 3, I know from my this equation that x plus 2y is 3, all right? And if y is 2 by 3, I got y equals 2 by 3, but at the same time x plus 2y must be 3, which means x plus 2 times 2 by 3 must be 3, which means x plus 4 by 3 must be 3, which means x is just 3 minus 4 by 3. You can write this as 9 by 3 minus 4 by 3, and which is 5 by 3. So the solution to the set of equation is x equals 5 by 3 and y equals 2 by 3. And you can pretty much verify that this also satisfies this particular case. So 2 times 5 by 3 would be 10 by 3, 2 by 3, that is 12 by 3, which is indeed 4. And that's what the equation is. So essentially, this is one of the ideas. So what you do, you try to eliminate one variable. We had two equations in two variables, and I converted it to a single equation in single variable. So what you can do is multiply one of the equations by a number such that the coefficient of a particular variable becomes equal, and then you can just logically do this and get the solution. Or what you can say is, once you get this, you could say subtract these two equations. And if you subtract these two equations, I mean, you can subtract equations, right? If a is equal to 2 and if b is also equal to 2, it means a minus b is 0, right? That's same as subtracting these two equations. So you could have subtracted these two equations and you could have directly said that so 2x and 2x would get cancelled. Let me write it down here. 2x plus 4y is 6. At the same time, 2x plus y is 4. So you could just subtract these two equations and say 4y minus y, that's 3y, is 6 minus 4, that is 2, and y equals 2 by 3. And you could substitute this value in either of the two equations. I substituted it here in this equation. Even if I were to substitute it in the second equation, let's say 2x plus y is 4, which means 2 times x would be 4 minus 2 by 3. This can be rewritten as 12 by 3 minus 2 by 3, which is just 10 by 3, which means x is just 5 by 3. I get the same solution. Alright, so the idea is multiply any one of the equations by some number such that the coefficient here and the coefficient here becomes equal, and then you can just subtract the two equations to effectively get one equation in one variable and then resubstitute that to get the other variable. In the same equation, if I have 2x plus what was my equation? 2x plus y is 3, I believe. No, sorry. My equations were, what were my equations? So x plus 2y is 3 and simultaneously 2x plus y is 4. These were my equations. So instead of multiplying this equation by 2, you could have also multiplied this equation by 2. Okay, so you would have got 4x plus 2y is 8, and then you could have subtracted this equation and this equation. So you could have got that 3x is 5 and x is 5 by 3. You get the same solution. So you could have either made the coefficients of x the same and solve, or you could make the coefficients of y the same and solve. Now there could be certain problems, such as, let's say, 2x plus 3y is 5, and let's say, can I say? Let's say x, okay, suppose I have 3x plus 2y is also 5. So now I have two equations in two variables. Now you can see that if you multiply this by, okay, in principle, yes, you could multiply this by 3 by 2. And if you multiply this equation by 3 by 2, the coefficient here will become 3x, and you can subtract these two equations. Or you could multiply this equation by 3 by 2, so that the coefficient of y becomes the same, and you can subtract the two equations. But usually multiplying by 3 by 2 seems weird, so you could also, what you could do is multiply this equation by 3 and multiply this equation by 2, so that you get 6 times x here and you also get 6 times x here, and you can then subtract. Or what you could do is you can multiply this equation by 2, multiply this equation by 3, so that you get 6y here and you get 6y here, and you can subtract. So essentially the idea is multiply the equations by some numbers so that the coefficient of one of the variables becomes equal, and then you can subtract out and get the answer. Okay. Or there is one more way of solving. Let me take the first example again. X plus 2y was 3. X plus 2y was 3. And I had 2x plus y was 4. Okay, this was my original example. What I could do is I could say, because x plus 2y is 3, that means x must be 3 minus 2y, right? And if x is 3 minus 2y, and if 2x plus y is 4, that means 2 times 3 minus 2y, 2 times x, but x is this, plus y should be equal to 4. And I get 6 minus 4y plus y equals 4. I essentially get the same equation. This is, instead of multiplying the equations and eliminating one of them, you can do a direct substitution. You can substitute x in terms of y directly in the other equation. Or you could also substitute y in terms of x in this equation. Anyway, we could get the solution. So I've just briefly discussed how you can solve a set of linear equations very easily. All right. The same idea can be applied for three equations in three variables as well. Suppose I have x plus y plus z equals 1. I have x minus y plus z is 1, and say I have x minus y minus z is minus 1. So you could apply the same idea. Here it's actually very convenient. I don't have to multiply it by anything. So it's as if just multiplying by 1, multiply by 1. So what does that mean? That means that the coefficients of x here are the same. Uh, Perhaps I've taken a very easy example, but even for any complicated system, you can solve it in the same manner. Say 2x plus 2y plus z is 5. Let's say 2x plus 3y plus z is 7. And let's say x plus y plus z, or the x plus y plus 5z is 9. So these three equations, what you can do is, because the coefficients are same, you can subtract these two equations. So you will get, essentially, what will you get? You will get, if you subtract, you will get y, or again, I'm taking a very easy example. Let's make this 2. So if I have 2x plus 2y plus 2z is 5, 2x plus 3y plus z is 7, and if I subtract these two equations, I'll get y minus z is 2. I'll get one such equation. And what you can do is, perhaps you could multiply this equation by 2. So we'll get 2x plus, or yeah, 2y plus 10z is 9. And then we could subtract these two equations, this one and this one. That will give me y. What will that give me? Y z minus 9z is just 7 minus, or I multiplied this by 2, right? So this should be 18. 7 minus 18, that's minus 11. So now I have two equations in two variables. I can solve this as I solved the previous example. can get the value of y, I can get the value of z, and then I can substitute in any of the equations to get the value of x. Here, this was a simple equation. You could have solved it in a better manner, but the idea is this. So, if you have two equations, two variables, eliminate a variable, substitute a variable, and by manipulation such that you get a single linear equation. If you have three equations in three variables, what you could do is you could do some manipulations so that you could get two equations in two variables, solve them, and then resubstitute these values to get x, right? So you could keep on doing this in general for n equations in n variables. However, this is a very cumbersome process if you have four equations in four variables or five equations in five variables. You can just imagine the amount of complexity that would be involved. So for n equation in n variables, I'm not discussing it right now. This is what we have done so far is a revision of high school mathematics, and this is sufficient to move forward, learn, revise coordinate geometry, and start with calculus, functions, and stuff. But in the same mathematics, so here what we have learned so far is sufficient to get us started. But in our mathematics bridge course, that is in our YouTube channel, you can find a playlist. You will find a playlist named matrices and determinants, or perhaps it will be named as linear algebra. So in that particular playlist, or in that particular course, we would cover how to solve three equations in three variables, four equations in four variables, or five equations in five variables, or in general, n equations in n variables. How to solve such systems in a very elegant and systematic manner. That is a topic for matrices and determinants part. So far, if you're right from high school, what you have learned so far is sufficient. There's a little bit more to the theory of linear equations, but I would talk about it when we learn coordinate geometry, and I would cover it up over there. But for now, uh, I hope that you know what an equation is, what is a variable, what is a linear equation, what is a solution to a linear equation, and how can you solve a system of two linear equations in two variables. Okay, so that's it for the video. Thank you.